of central tendency of ungrouped data. Measure of central tendency. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within the set of data. The mean, median, mode, and mid-range are valid measures of central tendency, but under different conditions. Some measures of central tendency become more appropriate to use than others. We will now look at the following sections and learn how to calculate them and what condition they are most appropriate to be used. Mean. The mean is the value of each observation in the dataset divided by the number of observations. This is also known as the arithmetic mean. Properties of mean. First, algebraic sum of the deviation of the item in a series from the arithmetic mean is 0. Second, the sum of square of the deviation of the items from the arithmetic mean is minimum. Third, the product of arithmetic mean and number of observation in which the mean is based is equal to the sum of all given values. Classification. Population mean is indicated by this symbol, pronounced as mu. Sample mean is indicated by this symbol and pronounced as x bar. Population mean. Population mean is equal to the sum of all x's over the total number of values in the population. Sample mean. Sample mean is equal to the sum of all x's over total number of values in the sample. Examples. Problem 1. This is the retirement age distribution. Find its mean. 54, 54, 54, 55, 56, 57, 57, 58, 58, 60, and 60. The mean is calculated by adding all the values in the data. So, the sum of all data is 623. Then dividing it by the number of observation, 11. So the sum of all x's is 623 divided by the total number of observation, 20, is equal to 56.6. So 56.6 is the mean of the retirement age distribution given. Problem 2. In a class, there are 20 students and they have secured a percentage of 88, 82, 88, 85, 84, 80, 81, 82, 83, 85, 84, 74, 75, 76, 89, 90, 89, 80, 82, and 83. Find the mean percentage obtained by the class. With a solution. Divided by the number of observation, 20. So 1660 divided by 20 is equal to 83. So 83 is the mean percentage obtained by the class. Try this. Number 1. 6 friends in a biology class have received test grades of 92, 84, 65, 76, 88, and 90. Find the mean of these test scores. Number 2. Find the mean of the marks obtained by 30 students of class 9 of a school. Weighted mean. The weighted mean is a type of mean that is calculated by multiplying the weight associated with a particular event or outcome with its associated quantitative outcome and then summing all the products together. The formula for finding the weighted mean would be weighted mean is equal to the sum of f of x over the sum of x. Examples. Problem 1. Using the information below, calculate the GPA or grade point average of the students for this class, hours, grade, points. By applying the formula, we get weighted mean equals f of x over sum of x is equal to 44 over 14. So 44 over 14 is equal to 3.14. Therefore, 3.14 is the GPA of the students. Problem 2. In a class of 20, 8 students averaged score of 86, 7 had average of 74, and 5 students had an average test score of 98. What is the weighted mean of the test scores for the entire class? Using the formula, we get weighted mean equals sum of f of x over sum of x, so equals 8 multiplied by 86 added to 7 multiplied to 74 plus 5 times 98 over 20. So equals 688 plus 318 plus 490 over 20. Next is 1696 over 20 is equal to 84.8. So 84.8 is the weighted mean of the entire class for their test scores. Try this. Number 1. Calculate the weighted mean of the sample of numbers shown below: 16, 20, 12, 16, 16, 10, 16, 20, and 20. Number 2. In a class of 20, 8 students averaged a score of 86, 7 had an average of 74, and 5 students had an average test scores of 98. What is the weighted mean of the test scores for the entire class? Median. The median is the middle score for a set of data that has been arranged in order of magnitude. To calculate the median of a data, step 1. Arrange the data from the lowest digit to the highest digit. And step 2. Locate the middle mark. N is equal to the number of observation. If n is odd, the middle mark is the median. If n is even, add the two values in the middle mark, then divide by 2. Examples. Problem number 1. The number of cars in a 9 parking lot on a hotel is 20, 13, 18, 22, 24, 23, 28, 14, and 30. Find the median. Solution. Following the steps, step 1 says to arrange the values from lowest to highest, so we'll get 13, 14, 18, 20, 22, 23, 24, 28, and 30. Step 2 says to locate the midpoint. Since 22 is the middlemost part, 22 is the median. Problem 2. 10 people purchased these numbers of seats in the cinema: 10, 12, 11, 13, 16, 20, 16, 15, 14, and 17. Find the median. 10, 11, 12, 13, 14, 15, 16, 17, 20. Seeing that the number of observations are even, we take the two innermost part of the data and divide it by 2, with MD being the median. Median is equal to 15 plus 16 over 2. So equals 31 over 2. So the median is 15.5. Try this. Number 1. Jessie's math teacher said that their final class grade is based on the average of all exam grades. Jessie has gotten 93, 87, 71, and 97 on her math exams. What is her final grade? Number 2. Megan wants to get an accurate picture of household salary in her neighborhood. The salaries for people in her neighborhood are 87,000, 94,400, 103,000, 97,000, and 55,000. What is the answer to Megan's problem? Mode. The mode is the most commonly occurring value in a distribution. Things to know about the mode. There can be more than one mode in a set. If there's only one mode, the set is said to be unimodal. Bimodal if there's two, and so on, would be identified as multimodal. It may not always exist in certain sets. Sets would be identified as no mode. To find it, just identify the values or valises in set with the highest frequency. Examples. Problem 1. In a certain data, the values are 6, 8, 9, 3, 4, 6, 7, 6, and 3. To find the mode, you could first organize it in a table to be formal. It's like this, where x is the given value and f is the frequency of the value. Or, put the data in ascending order and just look at the value that is the most repetitive. 3, 3, 4, 6, 6, 6, 7, 8, and 9. Therefore, the mode of this certain data is 6. Problem 2. This table has data of all ages of students in certain class. Find the mode of the data. Ages in class C. Organize the data by using a table, where x is the given value and f the frequency of the value. Therefore, the two modes are 20 and 21. The data is bimodal. Try this. Number 1. The data given is below. Find the mode. 46.4, 29.3, 48.2, 35.1, 46.4, 39.5, 41.3, 25.2. Number 2. Find the mode for the certain data. 99, 23, 71, 18, 14, 50, 13, and 37. Mid-range. The mid-range is another type way to find the average or mean of a certain data. It is found by adding the lowest value to the highest value and then dividing it by 2. Its formula would be mid-range is equal to lowest value added to the highest value over 2. Examples. Problem 1. Current cell phone prices are now ranging from $40 to $550. Find the mid-range. Using the formula for mid-range, we get mid-range equals lowest value plus highest value over 2 equals 40 plus 550 over 2 equals 590 over 2. Therefore, the mid-range for cell phone prices currently is $295. Problem 2. The weather service reports that a mean daily temperature is blank degrees. The data provided for the daily temperature is 55, 65, 67, 69, 70, 80, 81, 87, and 99. To find the mid-range of the data, we take the highest value 99 and add it to the lowest value 55 or vice versa. Then divide them by 2. Hence, we get 77. Because if you add 55 to 99 over 2, you go 154 over 2, then 77. Therefore, the mean daily temperature of what was reported is 77 degrees. Try this. Number 1. Find the mid-range for the number of calories in a meat hog for the brands. 173, 191, 182, 190, 172, 147, 146, 138, 175, 136, 179, 153, 107, 195, 135, 140, and 138. Number 2. Find the mid-range of average undergraduate grade point average, or GPA, for the top 9 ranked medical schools listed below. 3.80, 3.86, 3.83, 3.78, 3.75, 3.75, 3.86, 3.70, and 3.74.